Okay, new class. So thanks everybody for being here. Since we got 3 new people here, just so you know, basically what Silicon Dojo is. So I've been doing technology since 1996 when I shipped off to the Army. I've been doing tech education online since 2009. And basically in 2009, the idea was, hey, what if there was technology education that was available, on demand for free? Been about 16 or 17 years, things change. And so basically my thought process now is, what if we brought technology education back into the physical world, but basically with the same concepts as YouTube. So the idea is you just show up, you learn, you're empowered to do whatever it is you want to do, and you go home, right? We don't try to, kick people out or decide who should be here or not. If you want to be here, you get to be here. If you don't want to be here, don't be here. That's basically the idea. We do have a business, but I'm not allowed to talk about it because we're in the library. If you want to know what's going on with Silicon Dojo, so all of our RSVP system is currently through Meetup. So we have 2 meetups, one for Asheville, one for Durham. SiliconDojo.com, though, is the central place for everything. So we have this class tonight here in Asheville. Next Wednesday, we have a class on vector databases in Durham. The tech jobs, that's getting canceled for a while. We're going to have a class on Intro to AI with SQL here in Asheville on the 28th. And then we're also going to have an Intro to Systems Architecture in Durham on the 29th. So these are classes that are coming up here. Just so you know, I am going to start focusing. These classes here are all night classes like this one is. I am going to start focusing more on boot camps. Because of my YouTube personality, I've got like 1.1 million subscribers. People actually are willing to fly in. Again, it's this weird thing. And so I want to give them like a value proposition. And so one of the things we're going to start doing more in Asheville and in Durham is doing 1- and 2-day full-day classes. So in May, we're going to have a full-day class on something called Django. And basically the idea is that you can come in, you get a full-day class, you basically learn the subject, and then hopefully you can go and use it in your own life or world or whatever. But anyways, this is SiliconDojo.com. All the classes that we do, I do try to record. There's no guarantee on the quality if this works out, but if you want to watch a class later, it is here, and you can see all the classes we've been doing since October are up here. We have fireside chats with real technology professionals if you're interested, and we have 4 self-study programs. We're going to have more of these, but for classes like Introduction to Programming, Introduction to Python, SQL, and this Model Web App Framework, these are all self-study programs, basically like Udemy, something like that. You can just come here and learn. So if you want to learn more about Python, it's a 48-part series, so you can learn about VENVs and loops and function calls and all that kind of stuff there. So all of that is there. With these classes, one of the ideas is that they should be replicatable and that people should be able to copy them. So that's one of the interesting things. So I have people all around the world that have learned from me. And the concept here is, what if we can create an education program that people can copy? So all these classes are on GitHub. If you want to teach these to your organization, whatever else, you can take this information and use it as you see fit. And finally, just so you know, EliTheComputerGuy.com does exist. So these are the videos that I was working on for quite a long time. So a lot of them are old at this point in time, but if you want to come here, there are just a ton of classes and educational material if you're interested. So that's at EliTheComputerGuy.com. And that is it for the intro stuff. Any questions? No? Cool. Let's dive into the class. Oh. Yep.
So you have a YouTube channel, right?
Yep.
Oh, that's cool. What's your YouTube channel's name?
It's called Eli the Computer Guy. Though I would not recommend you watch it anymore. It used to be good. It used to be something I had pride in. I don't have too much pride in it anymore. Anyways, but yes, it's there. Eli the Computer Guy. What?
Are you doing any political commentary on your channel?
Well, I've been screaming about you hear about the aluminum stuff that just got bombed? Anyways. Oh yeah, that's real. Anyways, we stay out of that. This is Silicon Dojo. We don't go into the YouTube world. YouTube exists.
My dad's in Qatar, so it's pretty cool.
It's pretty cool. Well,
This guy missiles flying there every day. It's like, oh, they're pretty down. So they'll fire down.
Jesus.
Yeah.
Yeah, so anyways.
It's a different meetup.
Yeah, we'll just stay out of all of that kind of stuff right now. Okay. So let's take a look at this. So basically we're going to be dealing with the OpenAI API today. So our last class we did here 2 weeks ago was on the on OLAMA. So Ollama is an LLM or an AI framework that allows you to run things locally on your own computer. The nice part about it, it's really cool. It's free, so you can just use it as much as you want. Depending on the power of your computer, you can run pretty big models. So I have the new M5 MacBook Pro, and I can run the GPT, so OpenAI's open source model, 120 billion parameters. I'm actually getting about 80 tokens per second on that thing. So what's really cool with Ollama, what we taught before, is that you can actually run it on your system. So for security purposes, privacy purposes, all of that kind of stuff, it works great. The problem is it does require a lot of local resources. So basically, you need a pretty decent computer to be able to run one of these things. The idea with a local model is you need at least as much free RAM as the size of the model itself. So if you have, let's say, a 4 billion parameter model, it takes about 3 gigs of storage on your system. You're going to need at least 3 gigs of RAM in order to run that. If you have a 20 billion parameter model, you need at least like 16, 17 gigs of free RAM in order to run that. So the cool thing is with OpenAI and any of these APIs, basically what we're doing with APIs is we're able to have our code connect to somebody else's servers. So basically what's happening, like with this code we'll talk about in a second, is this code here, all that's running on the local machine is simply the little Python script. The real power, all the LLM power is actually being run on OpenAI servers. So if they're willing to burn $1 trillion for you to be able to get all of these services, I would much rather have them burn their money than me burn mine. The other cool part about this too is once you start using APIs, it really allows you to do some interesting stuff with architecture, because since all of this is running on somebody else's systems, the computer that you need to run your code on does not have to be that significant, right? So this is something called a Raspberry Pi Zero. It's a $10 or $12 computer. It has a 1 gigahertz processor, 512 megs of RAM, more than powerful enough to run Python, but it's not gonna run any LLM model. But the cool part is you can have this thing connect to OpenAI servers. OpenAI servers do all the powerful processing, send back the results, so you can use a $12 computer to get the results of a $5,000 system. So that's the cool part about OpenAI and basically APIs in general. So the class today is we're going to be teaching how to use the OpenAI API. Let's see here. So with this, again, you can use a crappy computer. For this kind of thing, you don't need an NVIDIA GPU. You don't need a GPU. You can use one of these crappy computers if you want. So whatever computer you have will be fine.
Windows computer?
Well, if you can get it to work. We're not getting political today. We're not getting political. We're not going to talk about aluminum plants or windows today. Anyways, in order to make any of this work, you are going to have to create your own account. What I will say is OpenAI's API is dirt cheap. We'll go into pricing in a second. Literally, depending on what model you're using, it comes out to 20 cents per million tokens. We'll talk about tokens in a few seconds. So like dirt cheap. Basically, you can put $10 into your account, and unless you're doing something really fancy, you can use $10 for the next 5 years, most likely, for a lot of the things that you're going to be doing. Now, to actually get an account, it's weird. Apparently, they have nobody that understands user interface design. So you go to openai.com and you get this, which you're not really sure what to do with. And so if you go to login, you can go down. So ChatGPT is the service that you normally use. You don't want ChatGPT, you want the API platform. You click on the API platform, it will give you this screen for how to sign up or log in, and then you go the process to actually get your API account. So the important thing is this is not, although they're owned by the same company, ChatGPT is one thing, OpenAI API is an entirely different thing, and how you get to this can be a bit wonky. If we go over here, we can take a look at this, or no, we won't get to that. So that's basically how you're able to access the API. In order to be able to run the code tonight, again, we do use VS Code as our IDE. If you understand what programming is, you can use whatever IDE you want. This is just what we use as standard for Silicon Dojo. There's a Python extension, which is standard for using Python. You will need a module called OpenAI. So basically, this is just within Within the Python world, anytime you want some kind of service or functionality, you basically have to install a module. So if you look at page 2 on the workbook, it'll just show you Python 3 --m pip install OpenAI, and that will install the OpenAI module for you. If you want to deal with environment variables, we'll talk about this in a minute. You also have to install that particular module. It's the python-.env, and that will allow you to have environment variables. Again, we'll talk about that in a minute. But that's the basic setup. So you need VS Code, you need the Python extension, you need OpenAI and an OpenAI account, and you need to install the OpenAI module. Pretty simple stuff. Let's see here. When you're thinking about the LLM architecture, there's things to be thinking about when you're dealing with APIs. Is one of the things to consider when you're thinking about whether to use Ollama or an API or like OpenAI's API is that a local server has high upfront costs but zero unexpected scaling costs. This is one big thing to be thinking about with the production, because especially a lot of new people, you're going to use this. It's going to be very inexpensive. You're going to be like, wow, this is wonderful, and you're going to want to put it into production. The issue is it may cost you, a couple of dollars every few months to run this on your own computer. You put this into a system where it's getting hit by 10,000 users per day, and the expense can go through the roof. The nice thing with having an Ollama server, it might cost you $20,000 to build that out. But that's the most you're going to pay. Like, it may crash, it may burn on you, but you're not going to have to worry about a huge bill. If you do something stupid with an API, you can get an incredibly large bill very quickly. So to be careful about that. Let's see here. APIs, if you're thinking about this, don't require a server administrator. This is an important thing in the modern world. Like if you're thinking about running a local LLM or something, or an API up on a server, is who's going to manage your server if you do it locally. So if you install Ollama on a local box, who's going to deal with that local box for updates, if it gets a virus, any of those kind of problems, things to be thinking about with that. One of the important things to understand with these APIs, though, is be very careful with the words that they use. One of the things you'll notice with any of these APIs, whether it's Anthropic or whether it's OpenAI, they will tell you very specifically what they won't train their little AI thing on. Like, we will not train the AI based off of the information that you give us. But they might train the AI off of things like the metadata. They might train the AI based off of where they know the communication is coming from. So one of the things to be very careful about is if you're in any kind of industry where you have proprietary information or personal information, data may leak in weird ways that you're not quite expecting. So be careful about that with the APIs. And again, a lot of these AI vendors at this point in time, it's important to understand they don't know what their business model is. Again, I get very snarky about this, but beyond the snark, like right now we have OpenAI has started an advertising model. So they said they weren't going to do advertising because they didn't need to do advertising because they were going to cure cancer. And well, they're not curing cancer, so now they're doing advertising. And so something to be careful about is, especially once you start using APIs, they want you to bury this deep into your systems. And so if they change their terms of service later, it might cause you some weird issues. So those are some of the kinds of things to be thinking about when you're thinking about like LLMs and APIs and all that kind of stuff. Let's see here. We're going to start looking at pricing. The pricing for this is just wackadoodle. So you can go to openai.com API pricing. So these are the flagship models. So these are the most advanced models out there. And so when we talk about a token is a word, a part of a word, or a symbol. So essentially a very basic back of the napkin math is 1,000 tokens equal about 750 words. You do that math and you should be fine. So what's amazing here is what you can now see. So GPT 5.4, the most capable model they have, is now $2.50 per million input tokens. And so when we talk about 1 million input tokens, apparently that is the entire Lord of the Rings trilogy plus the Hobbit book. So basically you can input all of that into what's called the context window for $2.50. You do have to be careful though, that's the input. Output tokens is $15 per million tokens. So basically it can write you the entire Lord of the Rings trilogy for $15 if you want it to. but that kind of gives you an idea of the price. And that's the most capable. The mini is, whatever, good for coding and computer use. You see it goes from $2.50 per million tokens to 75 cents per million tokens. I don't even know what that is, right? And it comes out to, for output, is $4.50 per million tokens of output. And then we go to GPT 5.4 Nano. It is 20 cents per million tokens and $1.25 for input and $1.25 for million tokens out. And so this is where we talk about it is, I don't even know what to do with those prices at this point. It is so cheap. And the thing to be careful with all of this, especially if you're going to be integrating this into your systems, is I question how viable that is. Again, for people that have been in the tech industry for a while, I've seen these boom and bust cycles, and things get really dirt cheap. You integrate it into your enterprise, and then the businesses actually need to figure out how to pay the rent, and then everything kind of goes to hell. So do be careful with this. Like, these prices are great, but it's also because they are just burning a tremendous amount of cash. Let's see here. When we go in and we actually take a look at OpenAI's platform, so once you're able to log in, let's see here. You're going to come to a page that looks like this. They have some different things up here you can play with. One of the big things is going to be your API keys. So this is where you're going to create your API keys. That's how you're actually going to be able to access their systems. You can see a usage here. Shows you how much you're actually using. Oops, one day. Anyway, oh, that's test. There we go. So for all my projects, we can see again, I've spent like 12 cents, 6 cents, 4 cents, 2 cents. So again, it really doesn't cost very much money. When we go here, we can take a look at, where is, oh Lordy. They really did change stuff here. Where is my, okay, usage. The big thing that you want is you want to be able, not fine tuning, oh, okay. So you click on settings. So you go over there, you can click on settings. The big thing that you want to take a look at is once you can get the settings, you see all these organizational stuff, general API keys, all that kind of thing. The big thing is you want to come down here to limits. So this is where you can set your organization budget. So that's going to be a big thing. Remember this API, they literally have a setting where not only does it charge your credit card, but it auto charges your credit card. So you want to come in here, and so for the entire organization, you can set what your monthly budget is. So I set it for $10 for the month, and it gives you alerts. The other thing is you have these different projects. So I have these different projects here. You can actually come down and you can create limits for each individual project. So let's say you're building something for your company. You want your company to have a $1,000 per month budget, but you're trying to do something in a lab environment. You give yourself a $5 budget for that thing in the lab environment to try to make sure you don't run into any problems. So that's where you can take a look at budgets and things. Projects, again, you can do multiple different projects here. You can simply go here to create a project if you want to create a project. And you come down here to manage projects. And there's not really too much to this. You can basically just say, you know, what the project is, and then for the different things that you're going to be developing.
Question on the pricing.
Yep.
How does that compare to cloud pricing? Because I did move away from OpenAI to cloud after the ad thing and the defense department thing.
Yeah.
So how does it compare to cloud?
Honestly, I haven't played a lot with Claude, so I'm not sure what the pricing is. I do know they're trying to be very competitive, so I'd have to believe it's relatively close, but I don't know exactly. Yeah. So from here, we can go over to the API documents. This is going to be the thing that's very useful for you if you actually want to start building your own little projects. This is where you can come to the side and you look at core concepts. If you click on these core concepts like text generation, This is where you can actually go and you can take a look and it will give you examples of the code, right? So basically you can just copy and paste this, and depending on what language you're using, you can get the code from that. So if you're doing text generation, this is just basically, where you ask it a question to answer it. You can do code generation, images and vision. So DALL-E allows you to create images. They also have a model for telling you what's inside of an image. We'll go over that today, so that's here. They have audio and speech. They have things like function calling. So basically, if you're trying to figure out how to do something, you can just come here, they'll give you the example, and then they'll give you the code that you can copy and paste, right? So that's when you log into the API dashboard. The big thing is make sure you set a limit for yourself, and then past that, you can come here to take a look at what's going on. Yeah.
So I just put in my details and got a limit.
Yeah.
There's 2 places to set a limit.
Yeah.
When you put in your billing information, it'll ask you, what do you want your initial transaction to be, and then when do you want your renewals to be, and then when do you want your monthly budget to be, and then there's limits inside of the API.
Yeah.
And the limits inside of the API are significantly higher than your billing limits.
Huh.
So, yeah, I just noticed, because I went into my limits and it's like $100, and I'm like, oh heck, no, $20.
Yeah. Okay. Yeah. Be careful about that. Yep. Let's see here. Okay, that's basically gone through that. Any questions with that stuff? Yep.
Yeah, the question on the pricing again.
Yep.
So earlier you showed the slide or the page where you've got the different, exactly this page.
Yep.
And you have the input price, and you've got the output price.
Yep.
The input price, like the amount of tokens or words you're putting into a prompt, and the output, what you're getting back, receiving from that prompt. So that's the case. You have to get the model. You have to set your limits so make sure that you're abiding by both the input and the output, right?
Yeah.
Okay.
Yeah, so it's like, so this is basically, you can put the entire Lord of the Rings trilogy in there, and that'll cost you $2.50. And then like, if you just say, I don't know, who was the first character to die? And then it would be like, a fraction of a penny to come out. Yeah.
If you want to summarize this in 2 pages, then it's going to be different.
Yeah. So yeah, the other thing too, as I did realize with these pricing, there's a lot of different stuff here with the pricing. With the images, so the images are the ones that might get you mucked up. So yeah, they kind of change the pricing here. Basically, when you do DALL-E, so I'll show you guys how to use DALL-E, it will cost you about 4 cents per image. So important thing to understand is when you're dealing with text, you can do text all day long as you're not putting entire books in, and it's not going to matter. Once you do start dealing with images, that is where you can run up a budget pretty quickly.
Are they not making Sora available as a?
Sora's dead now.
Oh.
You didn't hear Sora? No, like literally a couple days ago they just killed Sora. Yeah. Yeah, that was burning too much money.
So they don't have any video generation at all right now?
No, I think they killed it. Yeah, no, because Disney had like a $1 billion agreement, and they killed that. So yeah, that's gone. Okay, so there we go. So let's see here. We go back, we take a look at this. So we look at our API keys. Okay, the important thing to understand is when you create an API key, you just come in here, you can create the new API key. You can select what project that API key is for, so it can only be used on one particular project. And you can actually give it particular permissions. This is one thing, again, especially when you put things into production, when you start talking about cybersecurity, the idea is to decrease the plane of attack. If a hacker is able to compromise your systems, one of the ways to do that is if your systems simply don't have the permission to do specific things. So if your API key only has the permission to basically do text responses, then even if a hacker is able to compromise your system, they're not going to be able to create images. Right, so one of the things you can come through here, and they've got model capabilities, the different things. Do you want this to be able to use this or not? Basically, you can go through here and try to refine everything down. Once you actually do create this, though, all new, create secret. Why can't you do that? Oh, select project. Okay, once you create the secret, important thing, especially if you're new. this will be the last time you get access to the secret. So basically it's going to give you this here, you copy it. As soon as you say done, basically it will now show you the last 4 digits just so you can keep track of things. But beyond that, you will never be able to get access to that again. So do be careful there. What's that?
Where did you put it?
You copy and paste it to wherever is safe.
Any recommendations?
Again, like, so for these projects, you'll go into like your environment file here. It's basically where I put this. But again, there are key, what are called API key systems out there. You can put it into those types of things. Yeah. Okay. Let's see here. So one of the big things with this is if you are going to go into a production environment, you are supposed to use environment variables. OpenAI environment. So basically with this, this is the basic idea of how you're going to be able to access the OpenAI API. And I just want to kind of show you how this works. So from OpenAI, you're going to import OpenAI. So from the OpenAI module, you're going to import the OpenAI function. Basically what is going to happen here is this is how we're going to get our API key from an environment variable. So I've created this file called .env. In here we have OpenAI API key. And then I have the API key. It's important. No quotation marks around it. Just the API key. All right? So basically then what we do here is from the .env module, we're going to import load.env. We're going to then import the OS module. Load.env override equals true. This is important because sometimes your system will cache the API key. So if you have an API key, you delete it for whatever reason, you put a new API key into your environment variable, it might be using the previous one and all hell breaks loose. So get rid of caching. And then basically here we say API key equals os.getEnvironment OpenAI API key. So this is where we're able to get that environment variable. And then here we have client equals the OpenAI function, API key equals API key. And that's basically how we're able to feed the API key into this particular script. So again, basically when you're looking at it, you know, we got 5 lines of code there, and that's all just simply getting the API key into the script. And that's how you do it with environment variables. Past that, we come down here and response equals. So client.response create. We say what model we want to use. So GPT-5, GPT Nano, GPT Mini, whatever else. And then input, write a 1-sentence bedtime story about a unicorn. And then this is where we're able to print the response out onto the screen. So if we do this, we hit enter, it'll take a second. Surprisingly not as fast as you would think. But anyways, there you go, it does take a minute. So under a moonlight sky, a sleepy unicorn stitched dreams from starlight and dew, carrying them on soft hoofbeats to tuck beneath the pillows of children who believed. So basically that was able to go up there and pull that. Again, just so you see that it truly is dynamic about a hippo. So we just change that to a hippo. In the silver hush of moonlight, a gentle hippo drifted along lily pads, humming bubble lullabies as the river rocked her softly to sleep. So anyways. And that is basically how you're able to start getting some AI functionality. That's one of the big things with Silicon Dojo, as I say. AI is hard. The people that developed all this are incredibly smart. We're probably not that smart, but APIs are this easy. 15 lines of code and you get access to everything that they've been able to create. But this is the basic idea with environment variables. This is the last time I'm going to show you this tonight, just because this is a little bit more complicated, especially when you're new. But this is how you should do things. The idea here is that you do not want your API key to leak. You don't want your API key to go up to GitHub. You don't want your API key to get copied out somewhere and to get grabbed by a hacker. And so the idea is you create a .env file, and then you know just not to upload the .env file anywhere. You don't put that anywhere. You just put this code and be able to grab the environment variable. Does that all basically make sense? Cool. Okay, how we're going to be doing things for the rest of the class, though, is basically this. So this is a simpler way to do this when you're still playing around and you're new and you're trying to figure out why Llama module or modules aren't working on your system. Basically, this is how you can just plug the key in. So from OpenAI, import OpenAI, so we don't have any of that other stuff we had before. Key equals, and that's our API key, and then client equals OpenAI, API key equals key, and that's how we can feed the API key in there. So basically, to be clear, this is a very insecure way. Do not put this ever into a production environment, but when you're playing around with things, this might be easier for you to do instead of trying to figure out how to do the whole loading environment variables and all that kind of thing. Okay, any questions? Yeah. Cool. Okay, now let's look to text generation with OpenAI. Okay. So this is a basic script, so we're going to talk about this, right? So as before, so from the OpenAI module, we're going to import the OpenAI function. We're going to have the key here, so we're just going to put the key in, like I was showing you. And then this is how we are going to get a response from OpenAI. So client.responses.create. We're going to feed it what the model is that we want. And then here is basically where we're going to be making a query, right? So write a one-sentence joke about Louis Rossmann. If you don't know Louis Rossmann, it's an inside joke with Silicon Dojo. Don't worry about it too much. Anyways, so basically this is just the query. What we're going to do here is we're going to print out the entire response that we're going to get. I want you to see the entire response that we're going to get. Then I'm going to print out simply the output text, and then we can print out things like the total token usage. So when I'm going to print out the response, so when you get the response back, right? So response equals, and this is the call up to OpenAI. So when we do this, you're actually going to get a lot of information. Dun, dun, dun. Okay. So all of this from here, so this is the response, right? And when you do the response, you're going to get the content. So the text, this is probably what you're actually going to be caring about here. But beyond that, you get an ID for the request. So if you want to track that in your system, created at, you get a time code here if you want to track that in your system, the model that was used, and the date. I think this is kind of an interesting thing to look at, 2025-08-07. So when you're using models, this doesn't seem to be as bad as it used to be. So I started doing these classes about 3 years ago, and what I noticed is there used to be what's called AI or LLM drift, where they kept training the models, and they wouldn't necessarily tell you they were continue to train the models. So the answers that you got started to become different, even though you were using the same code and you thought you were using the exact same model. So by being able to track what the model is, and maybe by what the time code is, you can try to make sure you know what you're actually dealing with here. You can come down here, completed at, it gives you the time code for completed at, and a whole bunch of just other information. So again, once you get more into coding and when you're actually building out your systems, this might be useful for you. It gives you the output tokens. So how many tokens were used for the output? So 390 tokens were used for output. The total tokens used for this was 406 tokens. And so again, this is something that you might use for tracking. So like right now, there are some executives out there that are actually using how many tokens their employees are using as a metric. And so if you wanted to build your own internal system, when people were asking questions, you could actually track how many tokens they were using, and then a manager could pull that up and they could see a dashboard and they could see how many tokens people are using per day and that type of thing. That might be useful. Let me close this for a second. So that is what the response looks like. So then, if we just want the text, we can simply do, this is a shortcut, so response.output text. So this is built into the module that we installed. And so when I run this now, instead of getting all of that information we got before, We just get the joke about Louis Rossmann. Louis Rossmann can spot a bad backlight fuse from across the room and then turn it into a 20-minute rant on right to repair before the flux even dries. So if you know Louis Rossmann, that's funny. But anyways, that's how you're able to get just the text out. You can also, if you know programming, there's something called a JSON output. So you can use JSON to get to the exact same thing. So you do response.output at index 1, .content at index 0, .text, and that will also get the text out to you. So this is something that functionally works, but you generally should not use the other way. Using the shortcut is the proper way of doing it. But it should work. Dun, dun, dun. There we go. Louis Rossmann walks into an Apple store and the Genius Bar suddenly remembers where it left all the screws and schematics. I don't know. So basically, that's how you can get the text out. Now, the final thing here is, again, for the shortcuts, one of the things you might want to do is, again, track things like total token usage. So response.usage.total tokens. And that's using that shortcut to be able to pull the total tokens that were used out of this. And so again, if you're building a more complicated system, you can try to track that. So again, it shows you 352 tokens were in total used for this particular query. And that's the basic idea with just generic text generation. Any questions there? No? All right, you all are easy tonight. Okay. So model testing. So again, so we talk about, so we go to page 10. We go to page 10. So one of the things is when you're looking at these different models, again, they have different price points. They have different how long it takes to respond. This is one thing you're going to have to be thinking when you're dealing with actual users is what is an appropriate response time. So I've talked about this in other classes with Raspberry Pis. So there's an Ollama model you can put onto a Raspberry Pi that can do vision. So basically you can ask it a question about an image, but it takes 5 minutes to give you a response back. And so one of the questions to be thinking about, is that a good response time or a bad response time? If you have a library of 2,000 images, you add maybe 100 images per week, then having a $150 Raspberry Pi that's just processing 500 images per day, that might be fine if it's just doing it 24/7. On the other hand, if you're creating something like a new Instagram that has an AI component to it, you might want it obviously a hell of a lot faster. That's one of the things we're thinking about with these different models. So like with these models, it's cool. You can actually do voice. So you can talk to your computer. It can talk back to you. So when you think about latency, so many times we think about latency, we think about network latency, how long it takes your computer to talk to the server. But when you start dealing with these AI systems, it's the latency between your computer talking to your server, the server then processing the information that was given, the server then coming up with a response, the server then possibly turning that into a voice response, and then getting sent back. So all of a sudden, like 500 microseconds might not be bad if all you're doing is text input and output. But if you start doing voice, if you start doing video, you start doing other things, simply by being able to decrease the latency by 500 milliseconds might actually matter for you. So basically what we have with this particular example is we're able to use multiple different models for the exact same query to see what the response looks like, what the time looks like, that type of deal. So up here we have OpenAI, same thing we had before, the key, and then we create this function. So a function is basically just like a little program inside our code. And what we're going to do is we're going to loop through and we're going to use different models. So we have the GPT-5 model, the GPT-5 Nano model, and an old model called the GPT 3.5 Turbo model. Again, with these, one of the things you'll notice is some of them are more verbose, they're more talkative, some of them are less talkative. Again, they've got different voices. So for version and model, what this is going to do is it's going to loop through and it's going to try this for every single model that we have here. So we could have 5 or 10 or 20 models here. Speed, basically I want to know how long it's going to take for this entire process to work. So speed equals the time function. So we're going to import time. So basically what this is this is going to get us a time code here. Response equals So model, the version that comes in. So basically each model, it's going to try this, and then the query. So this is how you can start doing things programmatically instead of manually inserting the query. The query is just going into this function. So speed equals time.time minus speed. So we create the first speed value up here. We minus whatever the current time code is down here, and that gives us how long it took for this to run. We're going to print out the version. We're going to print out the speed in seconds, and we're going to print out the response. We come down here. This is a while true loop. So be very careful with while true loops with API calls. So basically a while true loop will continuously go on forever until you stop it. So again, if you start running an API call and you screw it up, and it just basically this will go as fast as your computer can run. So if you don't code this right, you will just start hammering the hell out of the API, and again, the price can go up pretty high. What we do here is we have this function. So input function allows me to type something in. So query equals the input function. Then we're going to print whatever the query is. We're going to send that query up to the AI function. And then basically whatever query is, it's going to run through these three models, and we're going to get this response back. So if I run this, your query, I don't know. Oh, who was the Tsar of Russia in, I don't know, 1780? So GPT-5, 6 seconds. Catherine II, who reigned from 1762 to 1796. Nano, there we go. Well, again, and this is the kind of interesting thing to take a look at. So the 5 nano is supposed to be faster, and a lot of times you'll see that it actually takes longer to run. Catherine II of Russia, she reigned as empress. So again, it's a little bit more verbose there. And then we have the GPT 3.5 Turbo, comes back in 1.3 seconds. In 1780, the Tsar of Russia was Catherine the Great. She ruled blase, blase, blase. And so again, this is one of those things where you can go through, and so you can take your query, you can loop it through multiple of these different models to see what the response is going to look like. Let's see here. Tell a joke about Louis Rossmann. Tell a joke about Louis Rossmann. Let's see how good they are on that one. Dum, dum, dum. 14 seconds on that one. I asked Louis Rossmann how to fix a water-damaged phone. He said, step 1, take it out of the rice. Step 2, bring it to someone with a microscope. It is Louis Rossmann. Don't know if that's too funny. That took 14 seconds to do. Wow, this is taking a while. Wake up. Oh, okay. Well, yeah, there you go. So 30 seconds. The nano model took 30 seconds, and it gave a nice big old response there. GPT, again, 3.5 Turbo came in at 1.2 seconds. Why did Louis Rossmann bring a flashlight to the computer repair shop? Because he heard they needed someone to shed some light on the situation. So anyways, and the curious thing here, again, depending on what you're doing, one of the things that we keep being told is that they need to do the frontier models. Like one of the things you'll notice right now is with Gemini Pro, Sam Altman decided that they were going to focus all of their energy on creating the frontier models. They're putting more and more money into that. And one of the interesting things is when you actually start looking at building these systems, what you start to realize is that the 3.5 Turbo model that I started teaching 3.5 years ago many times actually gives the best response. So it's just one of those things to kind of keep in mind. And yeah, it was fast. So it gives a better response, and it was, again, it was, yeah. Yeah, so yeah, the 3.5 Turbo is literally from, 2021, 2022. Whereas, again, the GPT-5, that's the current one, yeah. So that's one of those things you have to think about. Again, not just pricing, but, response times and that type of deal. Any questions on that? No? Cool. Then we can go to creating images. So this is pretty cool.
Sorry,
Yeah.
real quick.
Yeah.
Will it show up, in your in the OpenAI billing, which model you used and how much money you spent on each?
Does it show up in billing? Pay as you go, billing history, that's preferences. It's usage. So total tokens, it shows API capabilities, services, no usage, response, embeddings. Group. Yeah. Spend categories? Oh, okay, yeah, there you go. Yeah, so GPT-5, so it shows 6 cents, 807 input, output, nano, 3.5 turbo, yeah. Yeah, so, yep, yes, you can. Yep. Penny, yeah, it's less than a penny is the billing, so yeah. Cool, okay, yep, any other questions? Yep.
Doesn't OpenAI have a open source model, and does that mean it's on the laptop, or does it mean that you can API to that as well?
No, so they do have it, so yeah, it's open source. So that's when I talk about GPT OSS. So when we use Olama, so that actually is a very good model. I use it a lot, but yeah, that's entirely going to be on your system. Yep. Okay, cool. Okay, so then we go to images. So DALL-E 3, so DALL-E 3 is nice. Again, when I started doing this class a number of years ago, there was DALL-E 2, and DALL-E 2 showed you the concept, but it basically gave you nightmare fuel. Like you would ask it to give you an image, and it gave you an image, but oh, it was some horrible, horrible stuff. One of the big things to remember whenever you're going to be doing the image creation, though, and this is very important to remember, is for whatever reason, when you create the image, basically that image is going to be saved generally into an Azure bucket up on Microsoft systems, and it will exist for 1 hour. So something to be very careful about, especially if you're dealing with your boss, is you can put in a really good prompt, you can get an image, it will give you the URL for the image that was created. But if you do not download that image, in 61 minutes, it disappears forever. So be careful. That's one of the big ones. So let's see here. If we look at page 12, I'm gonna do the OpenAI image.
To me, is that one way for OpenAI to reduce its storage costs and not store every single image that's created by users across the board?
Yeah, it's a way to reduce the storage costs. I'm just kind of surprised it's an hour. I mean, it's not even 24 hours or a little bit longer. Yeah, but but they give you an hour and. Yeah. So we take a look at this. This is the code. Basically, we have the OpenAI like we had before. We're then going to have the request module. So basically with the request module, what we're going to do is we are actually going to get the image and save it so that it is actually going to be saved. So that's why we need the request module here. And then I'm going to import the time module, because this is a fun thing. Again, I don't know if I have real coders in the audience. One of the issues that you have to deal with is whenever you download an image, whenever you download a file from somewhere, you actually have to call it something, like figuring out the file name. So I just like giving it a timestamp, because when you give it a file name, you have to make sure you don't give it the same file name another file has, or that file will get overwritten. So you have to make sure it's unique. So by giving it a timestamp file name, hopefully, especially on a lab system, you shouldn't run into any problems. So that's why we're importing time here. So we come down here and we take a look at the model. Again, it's very simple. All this stuff is simple. So you're going to say what the model is, DALL-E 3. Prompt, I'm going to put a person riding a cat, and then you're going to give it a size. So there's a couple of different sizes you can give it. So 1024, 1024 is a good standard size. Image URL equals result. So the result that's going to come back, and then this is basically going to give you what the URL is. So the entire response is going to come back kind of like what I showed you before, but that is how you get to just the URL itself. I'm going to print result out so you can see all of the result. One of the cool things with DALL-E is it's going to give you a revised prompt. So again, with somebody like me, I'm really simple with things. Again, I just say a person riding a cat. One of the cool things is it will create a little story for you, and that's the revised prompt. And so you can save that. It's been, whenever you're dealing with content management systems, there's something called taxonomy. Again, that's kind of like how you can actually do searching and things on a system. So what's nice is you can save that revised prompt, and then you can do searching on it later. And then we're going to print out what the image URL is. Down here, image data. So basically what we're going to do is we're going to use that request module. We're going to get the data from the image URL, and basically we're going to get the content. So all this is basically where we're able to get the image data. And then what we're going to do is we're going to create a file name here. So with a file name, basically what we're going to do here is we're going to create a timestamp. So we're going to call this an int. So we're going to say a timestamp.png. So the file that's going to come back is a .png file. So basically we're just going to name it a timestamp.png. And down here we do with open. So the file name that we created, that timestamp, WB for bytes. So basically this is going to write as a file, as handler, handler.write image data. So basically we are going to write the image data to that file name, and it will save it somewhere up there. You'll see that. So we do a person riding a cat. We hit run here.
Does it automatically always make a PNG file?
Yeah, it's always going to be a PNG file. Yep. Yeah, so that's just one of their standards.
Can you designate a different file type for images or no?
Not as the last time I checked. I don't think so. PNG is just kind of the standard now. Just like JPEG was a standard in the 90s, PNG is just now. Yeah. So we print back the entire response. So this is going to be a response like we saw before. Again, in here you're going to have the revised prompt. You're going to have some other information in there, you know, timestamp when it was created, that type of deal. So the revised prompt, we pull that out. An imaginative scene featuring a middle-aged Caucasian woman adorned in a simple attire, carefully seated on the back of a giant, friendly domestic cat. So it created this entire story based off of that one little sentence. And then it gives me the URL here. If I click on this URL, so command.
Where does it hallucinate and dream that scenario?
I don't know. Yeah.
Fantastic.
Yeah.
Sorry, what was the input to get to that text output?
So all I did,
It was a person riding a cat.
yeah, person riding a cat. That was it. Yeah. So a person riding a cat while they eat a taco. I was going to go through.
Now, does it keep the same hallucinatory story?
No, it comes up entirely different. And that's going to be one of the big things with, yeah, let's see.
Vibrant, overflowing taco.
There we go. Yeah.
Have you ever asked it to go back to the other image and add a taco?
So it can't. So that's one of the things to be thinking about, again, with these AI systems. Again, they're not AI, they're models. That's one of the things I really try to talk about on Silicon Dojo, because when you say artificial intelligence, you put a big story onto what that actually means, where if you just say LLM, it's just a tool, it's a technology. So with any of this kind of stuff, it does not have a memory. It does not have that functionality until you give it to it. So that's one of the things, like when you use ChatGPT is both the models, the LLMs, plus a whole bunch of additional coding that goes along with it. The example that I give is like with Google, right? I can go to Google and not only can I ask for, you know, cat food recipes or whatever else, but I can also simply put in like a math equation and it will answer it for me. And the reason is that's not really being done through search. That's being done through, they create a little math algorithm so you can do that. And so that's one of the things to be careful about when you're using either the APIs or whether you're using Ollama, is you have to build that additional functionality if you want it to exist. Yeah.
What's in her left hand?
A soda, I think.
No, that's not a soda.
That's
That
like
was
a fried chicken in a cup.
right.
I-
Whatever's coming out.
I,
Could be a slushy.
I don't know. I don't know. I don't know.
I have a question.
Yep.
What if you want to keep that image but want to replace the cat with a doll or something?
That's what I'm saying. As far as this part is concerned, you can't do that. So with DALL-E 2, they may have changed it at this point. Again, I need to go back and do a little bit more research. With DALL-E 2, what you could do is you could actually put a mask. You could put like a mask over an area and basically say, replace that area with something else, and it could do that. But with DALL-E 3, you can't. No. That's the other thing too, is there are other image models. So you'll hear about multimodal models. So like with this image model understands what a cat is, it understands what a taco is, that type of deal. This image model doesn't know who Louis Rossmann is. So there's things called multimodal models. So there is the GPT-5 multimodal model. With that, you could literally say, Louis Rossmann fighting Tim Cook, and it would know who those two people are, and then would create an image based off of that. The reason that I don't demonstrate that in the class, though, is you actually have to hand over your government ID in order to get access to that, I guess because they're worried about, fake news or whatever. Yeah, that is something that exists. Any questions there with that? Yeah.
I noticed that there's where it says size. Can you change like any size you want for the image?
Size? So for 1024 by 1024?
Yeah.
Yeah, so you can change the size. I forget what sizes there are. A3 sizes. There we go. Available sizes. So you have square 1024 by 1024, widescreen 1792 by 1024. So that would be like a featured image or something. And then portrait, I guess, would be the other way. So you have those three sizes. Yeah.
So how is DALL-E different than the 4.0?
What's that?
How is DALL-E different than the 4.0 image generation model that OpenAI has?
So so they had DALL-E 2, so it's different. So there's the image generation API, multimodal models. So these are the other image generation. So the GPT image 1.5. So these are multimodal models. And so what the multimodal model is they know like people. So again, they know who Putin is, they know who Xi is, they know who Tim Cook is, they know, that type of things. And so you could plug in, I want Elon Musk eating a taco, and it would know who Elon Musk is. So that's the big difference there. Yeah. Any other questions? Cool. Okay, if we go over, take a look at page 14, we can look at computer vision. So this can be useful. And one thing too is, so these images get saved here just so you can see. So that image actually got saved locally, and this other image actually got saved locally. So again, something to be thinking about since you're burning 4 cents per time anyway. So we go over to page 14, we look at computer vision. OpenAI image. So now one of the things you have to be thinking about with architecture, whenever you're thinking about systems, is basically how is OpenAI actually going to be able to get access to the file? And this is something where you can have a very, very massive security vulnerability if you're not thinking what you're doing. Because basically, you make a query to OpenAI and you say, I want this, tell me about this image, right? Well, what you can do is you can have something just on the public web. So I just grabbed this particular image off of CNN.com. It's this football game. But something to be careful about, if you have an intern who wants to set up some kind of AI platform and they put all your contract information up on a public server, right? So that OpenAI can access it, you might run into a problem. So be careful about that. But basically with this is how you can use computer vision with OpenAI. This is a function like we did before. We have the key, as we did before. Response, and basically what we do here is model equals, so we can put in whatever computer vision model we want to use. We put in the query, so the query is going to come in through this function, and then you put a public facing URL to the image so that people can actually see it. So I think if I do this, So again, so this is the image file, and again, it's on CNN.com. Basically down here, we're going to do response.output text. So basically whatever the answer is. We're going to do the while true loop. We're going to have the input, response equals AI in the query. So the query is going to go up to the AI function. We're going to print out the query and the response. So I can do this, I can run this. And again, if we take a look at that, so we can say, let's see, how many people are in this image? There are 16 people visible in this image. But the cool part is you can say, who is playing? Image, professional football between Kansas City Chiefs and the Buffalo Bills. And so again, if you take a look at that, I guess so, I don't know much about football, right?
Wow, I can see.
Yep.
I mean, I guess that looks pretty obvious.
It's crazy.
Yeah. You can say, like, where is this? This image shows moment football between Kansas City and the Buffalo Bills. The game is taking place at the Kansas City Chiefs home stadium, Arrowhead Stadium. Again, who knows if that's a hallucination or not, but that's true. Oh, okay. Yeah.
Do you get everything from the image itself, or does it go to the URL of the CNN?
No, that's just the image. That's just the image. Yeah. And this is where they talk about things like the concern about privacy. So you're uploading images onto Instagram and all that kind of thing. Imagine when they're able to run these kind of queries against your image, like where is this? Who are these people? What are they doing? And storing all that kind of information. Yeah.
For the moment, though, like Instagram, they have protection against OpenAI being able to access those, right?
Well, yeah, but they're owned by Meta, and Meta is dropping $70 billion this year on AI, so they're doing this, yeah. So that's basically the idea here. And again, all of this is pretty simple. So you can basically just copy and paste. You can change the model if you want to play around with the model, and then you just put the URL of the image there. And again, you could process through. So again, let's say you have a website with a whole bunch of images. You could grab all the links from that website, for the image links from that website, and then process that to be able to pull out information that you're interested in. Again, if you're trying to stalk your ex-spouse or whatever else, you go to their Instagram, you can do the right click to find the URLs, and yeah, again, the interesting stuff of the modern world. Sorry, I have. What's that?
Upload from local?
Yeah, so that's the next one we're going to do. Yeah. So we go to 16. We do local. So OpenAI image file.py. There we go. So basically with this, we're going to need to import what's called the base64 module so that we can actually be able to upload. So we're going to encode, let's see here, let's do this. Boop. Okay, where are we doing? 64. Okay, that's how we're doing it. Okay, so basically what we do here is we give it an image path. So I'm going to give it a path to roxy.png. And roxy.png is my little puppy right there, sitting on a thing, right? So what we do here is base64 image. So we use the encode image function for the image path. So this is the image path, and then we're going to encode the image, right? This function here. So with image path, so that's the name of the image, RB. So we're going to read it as bytes, as image file. Return base.64, B64 encode, image file read, decode, UTF-8. So again, this is basically just a copy and paste thing. All this is doing is turning your image file into something that you can actually upload. If we come down here, basically, we have the response like we did before. What's in this image? And then here, what you do is you do data, image, JPEG, base64, and that base64 image. So basically, when we encoded that image, this is how we're able to send it up. And so then I can simply run this. And the image shows a small dog, likely a Chihuahua, lying on a patterned couch. The dog is resting next to a red textured pillow with the word camp written on it. Yeah. You can say like, what kind of dog is this? This adorable dog appears to be a Chihuahua. Chihuahuas are small dogs, blase, blase, blase. Yeah. Adorable. And this is one thing you're going to have to think about whenever you're dealing with any LLMs, is a lot of these LLMs are kind of like 80-year-olds who haven't seen a human being in a week. Like you start to talk with them and they're just like, you say, what kind of dog is this? And you want Chihuahua. Instead, you get a paragraph on Chihuahuas. So just something to consider. Yeah.
Then you would say in one word, what kind of dog is this?
What kind of dog is it? Let's see here. Answer in one word. Yeah, it depends on how persnickety it is. Chihuahua. There you go. You can do that. Yeah. So, but yeah, that's basically all it is. Again, this is all essentially just copy and paste for the code, but that's how you're able to upload from your systems. Do remember, from a security procedure, you are sending your data up to their servers, so you never really know what's happening with their servers. Again, if they're compromised or not, you're not really sure if your data can be compromised in the middle. So if you're dealing with things like personal identifiable information, healthcare, medical, any of that kind of stuff, be careful. This is absolutely awesome for, getting information about, your dog pictures, but be careful about other stuff. Yeah. Any questions there? All right. Cool. Yeah, that's good. Yeah. Again, you get $1 trillion in infrastructure for a fraction of a penny. Yeah. Okay, so then we can do text to speech. If we go to page 18, OpenAI text speech.
So you mean I can replace Siri?
Yeah. You've seen my examples. Yeah. So like this, just so you understand what we're doing.
Louis Rossman is a stinky face.
So there we go. Sorry, let me do that again.
Louis Rossman is a stinky face.
There you go, because we're just going to keep going with the joke, because there's nothing better than a bad joke. And the cool thing here is, like, all this is text. So the input is, Louis Rossman is a really stinky face. So this is what we're giving it. We're saying speak in a cheerful, positive tone. We're saying what voice to use. So we can use, let's say, echo. And we can say what speed. So we'll just leave it at 1.
Louis Rossman is a really stinky face.
Yeah. It's really good. Yeah. Let's see here. We can do Onyx. And you can also like speed it up. So we can go up to, let's say, 3.
Louis Rossman is a really stinky face.
And again, this is the cool stuff with all this AI, because what is difficult and complicated, what you need to be really smart about, is like dealing with multimedia files. How do you turn an image into text? That takes a brainiac. Once you have text, it's incredibly easy to deal with. Yep.
Is this creating a file called speech MP3?
Yeah, so this actually is creating the speech MP3 file, and then I'm using os.system to basically play it out, so that's how you're able to hear it. Yeah.
Can you download it if you want to?
Is it downloaded? Yeah, no, it must be downloaded, because it's, oh, my eyesight.
It's adding
Speech,
to your,
there we go.
your project path.
Yeah, so it's right there, yeah.
Louis Rossman is a really stinky face.
So, yeah.
Can you ask to speak in a different language?
Well, you could have it speak. Here, wait a minute. Let's do this. ChatGPT. Okay. Let's see. Hello, how are you in French? So what you would do is you would create it the French text, and then should work.
Also, you can just say,
Bonjour, comment ça va?
Yeah, that was a little fast, but yeah. So you could do 5 on 1.
But there
Bonjour, comment ça va?
So yeah.
there are APIs where you could convert the input, if it were English, to another language, and then use that as the input?
Well, so again, that's where you start talking about architecture and systems. So what you would do here, so there's something called the whisper model. So whisper model turns voice into text. So what I could say is take my voice, turn it into text, translate this text into another language, turn that text back into speech. And so you go through that kind of system, yeah. I do believe, again, you start paying a lot of money. I think Google now has language-to-language models, but that's, yeah.
In Gemini?
What's that?
In their Gemini?
I don't think it's in Gemini. So they have their,
Like add-on or?
yeah, because they have an API. So again, we're going to have a class on Gemini API later. So they have an API just like this system. And so I think within that, they now have language to language. And also you have to remember, it's weird. Like there's been this whole idea that Google was behind OpenAI. But Google's been working on this for like 20 years. Like the transformer model that's used for all these LLMs, Google actually created it back in like 2015. There's these things called TPUs, tensor processing units. Again, they came out in like 2014, 2015 from Google. So Google's been working on a lot of this, but it's all been like back-end infrastructure type stuff you don't necessarily see.
It's not front page.
Yep. So basically here, let's see here. Yep, okay, so we're gonna need to save that, so.
Can you change it to say speak like Eeyore? And what does it not?
Speak like Eeyore. I don't know. Like, how do you spell Eeyore?
E-E-O-R-E?
E-E-O-R-E.
E-E, yeah,
E-E-Y-O-R-E? Yeah, E-E-Y. All right, that's. That broke it. Oh, you did break it. What?
That's good enough. Just having to broke something.
What the hell?
Hello, Steve.
There we go. Cool. Let's see here. Speech file path. Anyway, so yeah, so basically, it's going to be the same stuff. We have from pathlib import path. So this is going to give us our path so we can actually save the file. So speech.mp3. So speech file path equals path file parent speech mp3. So what this is going to be doing is wherever we're at, whatever our current working directory is, it's going to do that. And then it's going to create a file called speech.mp3 there. Client audio speech with streaming. This is where you give it the model. So there are different models here. This is where you give it the voice. So I think in the book, there's more voices. There's about 7 or 8 voices. You do the speed. So speed is anywhere from 0.25 to 4. 0.25 is very slow. 4 is very fast. Input, whatever you want to say. And then instructions, basically any kind of additional stuff like Eeyore. As response, and then basically you can stream to file. So this is where you're going to save it to that MP3 file. And so from here, again, this is where we talk about architecture. Once you have that file, what are you going to do with it? If it's an audio book, you can send it out as an MP3. So here on a Mac computer, the command line MP3 player is called AF Play. So you install AF Play. And what we do here is os.system, AF Play, and then play speech.mp3. And that's what actually speaks this out. Again, all of this kind of stuff here is a bit convoluted. It is basically just copy and paste from them though and plug it in here. This here is with the input. This is where your code can be feeding things into this, like during a function call to actually get the response back. And this again is where we start talking about latency. So if we have a voice system, so I talk to the system, whisper, turns my voice into text. That text then has to go to the LLM. The LLM gives a response, and then this thing has to turn that back into voice to be sent to the user. And so that's where you do start getting into larger latencies. Any questions there? Oh, cool. Okay. Then we go to speech to text. Again, this is just from an audio file. So you can do this from a microphone, but that uses something called Pi Audio, which is a complete and utter disaster. So I'm not going to go into that tonight. OpenAI speech.text. Next. Again, all very simple stuff. So audio file M4A. Yeah. So where is my OpenAI? Okay, so I have this audio file. Oh, can I not play it? Here. Reveal in Finder. You get to see all my horrible music selection. Thank you. Thank you, Apple. Come on. Oh, Lordy. Come on.
Hello again. As you know, I am Eli, the computer guy, and this is a class for Silicon Dojo on the OpenAI API. As you know, I think Louis Rossmann is a stinky face. In my professional opinion, Louis...
All right, you got the point there. Again, joke is going on a little long. We get along, but anyways. So basically we have this big old audio file. And so this is the kind of thing to be thinking about, like, you know, if you have a meeting, so all of the audio in a meeting can be recorded, and then basically this can just be transcribed. So we have here, we have the audio file. We have RB, so for read as bytes. Transcript, client.audio transcription create. We feed it the model, GPT-4o transcribe, and then we feed it the audio file. Then basically here we can print out the entire transcription, or we can simply print out the text. So we do this. All right, so this is the entire response like I've shown you before. Output tokens, total tokens, the whole 9 yards. And this is where we can just get the text for what I said here. Hello again, as you know, I'm Eli the computer guy, and this is a class on Silicon Dojo, OpenAI. As you know, I think Louis Rossmann is a stinky face, in my professional opinion, so it is pretty good. All right, so you can actually build this into systems. What becomes really cool is you can actually do text segment, and so this is where it gives you timestamps. So imagine you have, again, a conference call or a video or whatever else. Not only do you need to be able to search to figure out what people talked about, but you actually want a timestamp around that. If you look at page 20, you have this segment. And so basically here, so OpenAI, the exact same audio file that we did before. We're using the Whisper 1 model here. Response format is verbose JSON, and then timestamp granularities segment. So this is going to give us a segment. For segment and transcript.segments, start equals segment.start, end equals segment.end, text, whatever the text is in the segment. Then we have an F string here. We start at the particular, we put in when we started, we put in where we ended, and we do the text. So basically with this, what you're able to do is we can see from 0 to 7 seconds, hello again, as you know, I'm Eli the computer guy. 7 seconds to 10 seconds, the OpenAI API. As you know, I think Louis Rossmann is a stinky face. Like, I want to know where the Louis Rossmann joke is. That easy, you find out it's at the 10.48 second mark.
How does it know which, like, how to create the break of the time?
Just like that. Is it based on inflection?
At that part, I don't know. Yeah, it must be like a pause or something. It's wherever it thinks there might be a pause in it. Yeah. Oops, is that blood? Did I cut myself? Anyways, this is dangerous work. No, it really is. No, seriously, did I cut myself?
I don't see any.
No, there's a little scout. Yeah. Anyways. So anyways.
Did you kill Louis Rossmann before you came?
Oh, well, that's what it is. That's what it is. So yeah, so this can give you that kind of thing, like timestamp and that type of deal, which is pretty cool. Oh, let's see here. Okay, then we can actually get to the labs. So that's basically the examples of what you're able to do today. Is there any questions on any of that kind of stuff? No? Okay. Then we'll get to the labs. So we got 3 labs. So this is stuff that you can do at home if you want to play around with, if we can get Steve's computer to actually work properly. And the idea is to show you how you can start building something that looks more like a real product. That's my wound on my arm. Okay, so let's go. So what is this script? OpenAI bottle. OpenAI bottle. Okay, so when you're building projects in Python, or basically with anything, you're going to build it with a lot of different components. So with Python, you're able to build web applications. But when I say that, it sounds a little bit easier than it actually is. Basically, with Python, you're able to use a Python framework, basically a web app framework, in order to build a web application. And so the web app framework that we use in Silicon Dojo most of the time is something called Bottle. And the reason that we use Bottle is because you can actually run it directly from the script. You don't have to have anything external. So basically what I can do here is this a little AI script. So I can run this, and it's going to tell me if I go to 127.0.0.1 at port 8080, I will get my little app. So cancel, give me my app, right? So basically what we get is we get this little web app here, right? And this is kind of showing you how you start to build something. So it says, how can I help? I can say, what is a taco? Hit submit. Oh, you thing. Incorrect API key provided. Oh. Hold on one second. Let me go back to my env. There. Oops. So port 8080. And so I can say, what is a taco? And I hit submit. There you go. A taco is a tortilla folded, wrapped around fillings like meat, cheese, beans, and salsa. So this is how I can now create a web application, something more that a user is going to actually want to interact with. And again, with the Bottle web app framework, you can actually deploy this online and run it, again, in your company or something like that. If we take a look at the code for this, it's pretty simple. So basically, again, we import OpenAI like we did before. When you're dealing with a Bottle web app framework, you have to import the different functions that you're going to need. So run, route, post, and request. Again, this will make more sense as you start to learn the Bottle web app framework. I am going to create an injection of answer in fewer than 20 words, because again, it does like to be verbose, right? We're going to come down here to route. So basically in the Bottle web app framework world, this is called a decorator to a function, and the route is essentially what page name you're talking about. So if I did about, or if I did home or whatever here, so if I did this as home, this would essentially be the home page, right? By simply doing the slash, that means the root directory. You can then put here a method, get or post, or get and post. Basically, can you send a value to it? So we have that little HTML form, so we can send a value to here. So query equals request.forms.get. So the value that comes in from query, we're going to put that here. So if there is a query value, the full query is the injection plus the query. Response equals AI query full. So we go up to the AI function, and basically here we just have our little AI code like we've had before. And so the response comes down here. Else, so if there isn't a value in query, it just simply says, please ask a question, and the response is nothing. We have our little HTML form here. So web app, form action, go to root, method equals post. How can I help? Text, and again, the name is query. So the value that comes from this text box is going to go up here. Then we're simply going to print out strong what the query was and what the response is. And then we're going to return the page. Down here for run, so host 127.0.0.1, that means the loopback address. And then port, most of these computers you can't run on port 80. So port 80 is the default port for HTTP. For many security reasons, you can't run it on port 80 by default most of the time. So port 8080 is an alternative HTTP port. And so that's what you get when you hit the run button. And so again, you come here, cancel, you say, how do you spell Eeyore from Winnie the Pooh? So now you can ask questions like, how do you spell Eeyore?
Well, I autocorrected your Eeyore to more.
Oh, did it? Oh, oops. Yeah, I hate autocorrect. Anyways, maybe it'll know. Oh, there you go. How do you spell it? Yeah, there you go. Yeah. Yeah. So, yeah. So that's the cool stuff. So again, like literally, this is, again, with a little bit more, we have a whole class on how you use Model, but you can actually build your own web application, AI-powered web application with this. Yeah. Any questions on that, lab? No? Cool. What's?
I figured out my environment.
Oh, did you? Yay! Tell me after this. Okay, the next one is a simple a simple image gallery lab. If we go to page 24, OpenAI DALL-E bottle.
So when you install these, the bottle and requests,
Yep.
do you have to do it every time? Or is that doing it right there?
No, it should be in your environment once you put it. Yeah. Yeah.
This is a basic API question, but
Yep.
why would it be the code you had to actually post a result? Why would the initial be a get to be able to get like send the request using the get and the post would be the actual result of the request?
So that's methods for how you're able to send data in HTTP. So post is kind of under the hood. So when you use an HTML form, it's almost always going to be post. Get is when you see the URL. So like when you go to Amazon.com and it has, there's Amazon.com and it says question mark and then a whole bunch of crap.
Right, UTM and all that. Yeah.
That's the get value. Yeah. So whenever you're dealing with forms, you're generally going to be dealing with post. Get is like, let's say you click, let's say you're looking at like a web page and you want to increase the size and the font, so you might hit like up. That might be sent using a get instead of, yeah. So that's the difference. Yep. So basically with this, same kind of stuff as we did before. One of the things though, as I'm putting in injection, add some pasta. So this is kind of one of the things I'm like really hammering on in all my classes for people to think about. Is we keep hearing about like fake news and misinformation. One of the things I'm curious about is the whole idea of micro influencing. The idea of what if you just add a tiny bit of something to 1,000 different images, right? Instead of trying to give you one bold-faced lie, we just lie a little bit over 1,000 different images. And so I always talk about like the spaghetti monster. It usually doesn't get me into trouble when I talk about religion. And so like one of my arguments is like, what if I went to you and I'm like, look, I can prove to you that spaghetti monster exists. Oh, how is that? Go back and look at all of these images and notice how there's always pasta in everything that you see. That shows you the spaghetti monster's noodly goodness. And so basically with this, we're going to be injecting pasta into everything that we do. We come down here, we have the route, get and post. So again, we have the query. If query, we do the injection and the query. Response equals AI for the full query, right? So we go up here to the AI. This is just going to be DALL-E 3, 1024 by 1024. We're going to get back the URL and we're going to get back the revised prompt, all right? So that is going to come back here. So response index 0 and response index 1. So the image URL is going to be at index 0. Revised prompt is going to be at index 1. So we're going to say with open gallery simple.csv append file.write the URL and the revised prompt. So a CSV file is a very simple way of basically creating a data file so you can read it later. Picture gallery equals the gallery function. So if we go up to the gallery function, what's going to happen is basically we're going to read that CSV file and we're going to turn it into a gallery. So just so you know, if you know anything a little bit about Python, we use A+ here so that if the file doesn't exist, it will be created. So whenever you're dealing with files, you can do W. So W means either create the file or overwrite the file. R means just read from the file. A generally means append to the file, add to the end. The problem is if you run this script the very first time and you don't have a gallery CSV file, it'll fail out because the file doesn't exist yet. You can't append to a file that doesn't already exist, so that's why we do the A+. We do the file.seek here, basically go to the first position in this file when we're going to be reading from it here. So pictures equals file.readLines. So basically every line in the CSV file is going to come back as an index in a list. Then we're going to say for image and pictures. So that's going to be the line. And then we're going to split based off of this bar here. So we take a look at the CSV file itself. Gallery simple CSV file. Is it there yet? Might not be there yet. Anyways, we'll take a look at that in a second. And then here is where we use CSS to actually try to create a gallery. So we're going to create an inline block. The width is going to be 200 pixels. The height is going to be auto. We're going to vertically align to the top. Then we're going to have the image in there. Width is going to be 100%. Height is going to be auto. SRC, so basically the URL, this is going to be the URL. So the image isn't going to be saved here. That's going to be the URL for the image that's going to be displayed. And then here we're going to have the description, that revised prompt, and we're going to return the gallery. So basically we come here, we have the form. So this is the form where we tell it to create us an image. We're going to do what the query is. We're going to give the response. That's just going to be printed back. And then we're going to have the image gallery here. If we go and we actually run this thing. Cancel. All right. Yep, the images are gone. These images are gone because it's been over an hour. So I can say a cat eating a taco with a mouse on the moon. Dun, 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 dun. There we go. So get back a cat eating a taco with a mouse on the moon. I'm going to be printing out the entire response here, again, just for kind of troubleshooting purposes, know what the hell is actually going on. And then we can see, so this image still exists because it's been less than an hour. So we have our cat eating a taco with a mouse on the moon. And then we have our little revised prompt there. I could say like a mouse eating a pizza with a dog on Mars. You know, I just take a look at that little bar up there to see how long this is taking. And so we scroll down. Oops. Come on now. Oh, and there we go. Okay, cancel. All right, so yeah, so we have a dog, we have a mouse eating pizza. It's on Mars. Yep. So this gives you the basic idea of how this works. So we're able to create the image based off of our query, and then both the image and the revised prompt are able to be shown in this particular gallery. Oops.
So every time you submit, it adds like a new image on top of the existing image?
Yeah, so basically, well, what happens is every time we submit, it goes to my little CSV file. Where's my CSV file? Simple gallery CSV file. Okay. So this is that CSV file I was kind of talking about. And so this is one thing. So this is, up there, you can see that link, and that's to the image. And then the blue is a revised prompt. So every time we create a new image, right? Picture this, a wide Mars landscape with reddish orange dirt, rocks in the sky with a dot of brilliance. So basically it keeps adding here. And then when we run our script, that is where we go through, and when we create the gallery, so when we go through this, we're gonna open that CSV file, And basically what we're doing here is we're reading from that CSV file in order to create that gallery that we're looking at. Yeah. Does that kind of make sense?
Yes.
Yeah, cool. All right, any questions with that? No? Okay, well, I'm actually gonna get done on time today. Okay, so then the final one, just so you see how all this works, it's a little bit more real. I'm trying to add more stuff that looks how it's supposed to look. If we go to page 28, OpenAI DALL-E bottle template. All right. So basically when we take a look at this, this is ugly in a lot of ways. The key is actually here. We're not downloading the images and we're actually writing all of the HTML directly in bottle. So again, this is a little bit more advanced, but we always use bottle. So you can do this. Obviously this works. This has no sanitization though. If somebody tries to put in injection attacks or whatever else, it might actually work here. What you really want to do is use something called a template file. And so that's where if we look at the lab, the DALL-E image gallery lab, what you'll notice is we have two files here. We have the template script, and then we also have what is called the index.tpl file. Let me just show you the index.tpl file real quick. Where is my index.tpl file? Okay. So this is an index.tpl file. So this uses what is called a template language. So again, a lot of people get in the technology world and they say, what language do I need to learn? And it's like a lot. Like even just for the simple thing, we're using Python, CSS, HTML, and a template language now. Basically what this does is we are able to submit data to this template, and then this template is going to dynamically write that data into a web page. So we have the HTML form here, like we did before. That looks pretty normal. We have the query, like we did before. The thing is here, you'll notice this, squiggly, squiggly, query, squiggly, squiggly. So we're going to send a variable value in the variable called query, and that's how we're able to print it out onto the screen. We're going to have the revised prompt, again, within the squiggles. And then here, we're actually going to dynamically create the gallery simply within this template. So the big thing is, with all these template languages, you normally start with that little percentage sign, and you say for item in gallery. So we're going to send a gallery list, and it's going to go through, and it's going to basically create the gallery for us. Item 0 and item 1. I'll show you how that goes through. And then we end. So if you're ever dealing with these template files, always do make sure you have to end the code block or it's not going to work properly. If we go over and we take a look at the script itself, again, slightly more complicated, but okay. So we got this whole mess. We got to bring in the top. We got to bring in OpenAI. We're going to bring in a whole bunch of things for Bottle. One of the big ones is static file. So whenever you're dealing with the Bottle web app framework, any Python web app frameworks, you're not actually supposed to host files locally, just from a security standpoint. So you have to add the static file function in. And then the template function allows us to use those templates. We have requests, we have time, we have OS, and we have .env like we had before. So we're going to load the .env file here, override equals true. We're going to create the injection, add some pasta. Let's see here. We're going to come down to our route. So basically, like we had before, so if a query value comes in, query full equals the injection plus the query, response equals AI query full. So we come up here. This looks like it did before, only instead of having the entire API key there, we're getting the environment variable. And then basically we're sending back the URL and the revised prompt. Image URL equals response 0, revised prompt equals response 1, image name equals download image URL. So if we go up to the download function, this is going to be our little function to actually download the image. So we're going to get the content, we're going to create a name, we're going to join to static. So this is going to go into the static folder. And so basically what we are going to be doing here is we're going to grab the image from the URL. We're going to create a name for that image. We're basically going to create a path, so to the static folder with the file name, and then we're going to save it here. So basically, static folder, we have a static folder up here, and we're going to save the name. Then we're going to return the file name so we know what it is. Here is the static folder function. So at route static file name. So we have a folder up here called static. So serve static file name, return static file, the file name from the root of static. Let's see here. With open gallery.csv, so the CSV file, A as file, dot write the image name with the revised prompt. So this will write the image name with the revised prompt, else don't do anything. So with open gallery.csv, A plus, create the file if it doesn't exist. Basically, we're going to read lines. Gallery, we're going to open this up as a list for image in pictures. So each line that comes back is going to be a value in a list. So for each image in that list, item equals, we're going to split based off of that line, gallery.append, item 0, item 1. Basically, what all this is going to do is it's going to read the CSV file. Each line in there, it's going to split into a file name and a revised prompt, and then we'll put that into a list. And then what we do down here is return template. So the template's name is index. Query, this is the value, is going to be query. Image URL equals image URL. Revised prompt equals revised prompt. Gallery equals gallery. All of that is what then gets sent to the index.tpl file. Here you're going to notice the src is static and then whatever the image name is. And basically what we get with this then is we get something that actually continues to run. Oops. Did I click on the right one? Oh, I did not click on the right one. How about I click on the right one? Okay, so now we run this. Okay, so these are the images that I was playing with earlier, and you can see obviously we've been here for over an hour and a half now, so they still exist. So there's a cat eating a taco on the moon with pasta, a cat eating a taco with a mouse under it, all kinds of weird, creepy stuff. Anyways, so I can say a dog, a cat, and a mouse eating pizza on the moon. Rise prompt, and if we go, where is it? There we go. We got, oops. We got a dog, a cat, a mouse, oh, and a space person eating pizza. But you'll notice there's some pasta in there too. Yeah.
Is it two cat? Is that a sloth?
It's a mouse. It's a, yeah, I don't know. I think that's supposed to be a cat and a dog and a person. The thing with this though is useful too is if we take a look here, if we look at the static folder, so all of these images are getting saved into my static folder. Yeah. There we go. And again, so you add this to a database. So we talk about SQLite database or Postgres or something like that. Again, you can start making this much more complicated, much more interesting. But this gives you a basic idea of what's going on. So these labs, hopefully, again, if you want to learn more about Python, hopefully they are understandable enough you can start playing with them on your own. Otherwise, yeah, that's the class for tonight. Is there any questions?
Yeah, I have a question.
Yeah.
I have everything that's behind the second tab, right?
Oh yeah. Oh, so with these books, you can take the paper, just not the 3-ring binder. So you can take you can take all of it if you want. Just don't take the binder.
Really?
Yeah.
So at work,
Yep.
I showed our lead architect a llama.
Oh.
Downloaded some models for him.
Yeah.
And he's freaking addicted. And so we wrote an errand justification for our business
Yeah.
using GPT.
No.
And he wanted some of these documents, and I'm like, I need them back.
No.
Now I can give them back.
Well, you know, it's all on GitHub too. You can just print it off of GitHub.
I don't understand.
Oh. Yeah.
So I was using the wrong model. In the bottom right hand where it says Python.
Yeah.
So my Python
Yeah.
I was selecting was a 3.14.
Yeah.
And then I switched it to use the default.
Oh.
And I started.
Oh, I know. Cool. So yeah, if you're interested in these, again, so our next class here, just so you know, well, I don't know if it's here. It's wherever I got the place. We are going to have a class here in Asheville. So Intro to AI with SQL. So SQL is what's called a relational database. We'll kind of show you the power of that. And it will be, what is it? The 28th. So I guess it's about a month from now, and it will be here if you're interested in coming back. We also do Durham if you want to drive all the way to Durham, but it's a ways. So
Thanks so much.
yeah.